Hi there, welcome to Adding and Subtracting Rationals. We are going to take a closer look at how we can simplify rationals when it involves addition and subtraction. We've already looked at multiplying and dividing, but adding and subtracting is going to get a little bit trickier. So before we jump into the Algebra 2 part, let's throw it back and take a closer look at fractions, because this is where the magic truly is going to happen. Because right now, if I try to subtract these fractions, I can't really do that because right now I've got these uncommon denominators. I need to make them look the same so that when I remove 5 9s, they're kind of getting removed from the same pie, if that helps. So how can I make those look the same? Well, 3 is almost a 9. I just need it to be multiplied by 3. So I can multiply the top and the bottom by 3. And then it just looks like 6/9. And you can kind of tell that those two fractions, these really are exactly the same. One's just gotten a little smaller along the way. Then I'm actually going to be left with 1/9 for a final answer in red. So pretty nice. So what's going to happen when we run into this problem where, 3 and 5, there's really no way to make the 3 a 5, and there's no way to make the 5 a 3. So now I need to come up with a number that they both would have in common, and I would have to multiply the top and bottom. So I'm going to make these fractions a little bit larger, and luckily 15 would actually get me there. So to make each of these a 15, I'm going to take the first fraction and multiply the top and bottom by 5. And then I can take the second one and multiply the top and the bottom by 3. So now I've got these bigger fractions, but at least they have the exact same denominator. And then I can subtract and get 1/15. So always ask yourself, do I have a common denominator? That is the biggest thing when you're working with types like this. So let's kick it off with the very first example. And what I like to do is always take a look at the denominator first. I don't even focus on the top. I do have common denominators. So just like what we did on the side, all I did was simply subtract the numerators. And that's exactly what's happening here. The tricky thing is that subtraction is applying to the entire piece. So be sure you use some parentheses to guide yourself. And then you'll see what I did with the denominators. See how it was out of 9? So the final answer was also out of 9. So here, you're just going to keep it as x squared plus 1. Very, very similar action. And then you're going to go ahead and do a little bit of distribution with that negative. So you can see I distributed that negative to every single thing. So this went in and this went in. And then just be sure for that final answer, combine like terms. For that final answer of -3x plus 3, and then again, don't forget the common denominator. Of course, you still have undefined issues. Where is the denominator going to go to 0? Okay, no worries. Here's what I liked about this problem, is if I tried to set the denominator equal to 0, I got square root of -1. Well, that's imaginary. So guess what? You get to use all values of x. You do not have any restrictions. There are no undefined numbers. I don't have to worry. So that one actually worked out pretty well. So railroad crossing. And yes, I will explain the railroads in class. So let's see. They both have an x, so I don't have to worry about that. But 3 and 7 have nothing. There's no way to make a 3 into a 7. But here's what I'm really good at. It's possible 3 and 7, well, that would have 21 in common. So on here, 21x is going to be the common denominator. So we are going to do exactly what we did before. I'm going to give this one a 7 on top and bottom. And I'm going to give this one, it's missing a 3, because that's what's going to make it 21. So top and bottom get a 3. And now they both have a common denominator of 21x. And that's always going to be the tricky thing with these, is how do I make them have a common denominator? And I just kind of like to do a give me game. You get basically what's missing. And then you can go ahead and simplify. So 14 plus 15 is 29 over 21x. All right, you know the drill. Undefined pieces. So focus on that denominator. Make sure it never, ever goes to 0. Well, I would just divide by 21. So as long as x isn't 0, everything is going to be fine. I won't worry about dividing. All right, this one, I like to highlight my denominators just to really see what's happening here. Well, those, again, don't look anything alike, but let's see if maybe I could try factoring, just like what we did the other day. So on this green one, I'm going to leave the m, hasn't really done anything. I always like to leave the numerators alone. Okay, what could I take out of the green piece? A 3. And then I'm left with m plus 2. Well, look at that. The other one has an m plus 2. It's just missing the 3. So to make sure I have that common denominator, this one's still going to stay the same, but I'm going to give this one a 3. I'm going to multiply the top and the bottom. So now I have common denominators. So the top is now a 12m, and there's my new denominator. Okay, looks good. Now I just need to do a little subtraction. So I'm just going to do m minus 12m and give me negative 11m all over the common denominator. Same thing like before. Are there any spots where I'm undefined? So you can either take the entire piece or you can just worry about the m part because that's really what our concern is. So as long as you have negative 2, you're good to go. Oh, I got lots going on here. So first thing, those don't look like anything in common. So you'll see I leave the numerators alone. And this is where, you've guessed it, factoring is going to help us. So on this blue one, my goal is to somehow get to 6, somehow add to 5. And luckily, there is a combination out there. Happens to be 2 and 3. So x plus 2 and x plus 3 will be the factors. And I can do the same thing on the green one. So I'm going to do a little x over here on the side, multiply to 4 and add to 4. Well, that's kind of an interesting idea. 2 and 2. So I've got x plus 2 and x plus 2. Okay. Common denominator. This is where I try to think of what do they have in common, and if they don't have it, let's just do a tradesies. So here is where maybe a highlighter can help. Okay, they both have an x plus 2. So then here's an x plus 2. Oh, well, the other two pieces are different. So to make these look the same, here's where we're going to give a little. So it looks like I have 2 of these pieces. So this piece needs an extra x plus 2 because I have 2 of them over here. So I'm going to give you an x plus 2 on top and on bottom. All right, what are you missing? Ooh, you're missing the x plus 3 piece on top and on bottom. Remember, if you multiply the top by that, you'd multiply the bottom, just like how we did with our first examples. And then if you want, yes, you can always highlight the sign you're working with. So I am subtracting, so I always like to make sure I see that. So here's my common denominator, all 3 pieces. And then here's my final numerator. So you can see that I've distributed that x into everything. So here's x squared plus 2x, and then big minus sign. And then I kind of have something that looks like this. So if you want to take this minus sign, here's a little trick that Miss Hawkins likes to do. I like to change this to a plus, and then I attach the negative over there so that when I do distribute, I don't lose track of it. So that's where I got my negative 2x and the minus 6 from. And then combine all of your like terms. Well, this worked out pretty well because I just have x squared minus 6 on top and the common denominator on the bottom. Yes, and don't forget your undefined. Well, I basically have two pieces, two numbers that are undefined on the bottom. So just as long as I don't go to -2 and -3, you'll kind of see I've got matching x plus 2s. So that's why I only have two undefined values. And I'm pretty sure x squared minus 6 does not factor further. So I don't need to keep going. All right, so on this one, you can see I've already left the numerators the same, so now I'm focused on my denominators. So let's focus on the green piece, because right now these don't look anything alike. Well, the good news is I see an x squared minus 9, and I am really good at perfect squares because x clearly got squared, and what got squared to give me 9? Okay, that must have been a 3. So difference of squares for the win. Again, lots of really great shortcuts here. And then on the blue piece, I definitely see a 6 and a 2. And then I think I'm also going to take out that hidden negative. So if I take a -2 out, okay, now my pieces are starting to look similar. Here's the good news. Right here, 4 divided by -2. Yes, you can absolutely simplify before you keep going, because here I'm going to get a -2. And here's some good news for you. You've got a negative and a negative. So here's this piece. It's just going to stay the same. And now I just have a 2 left on top. And you can see that I changed this one to a positive because I've got double minuses. And I still have an x minus 3. Okay, now I need to do common denominators. What does one have that the other doesn't? Well, this one actually works out pretty nice because they both have an x minus 3. This one has an x plus 3. This one is missing it. So I'm just simply going to give the top and the bottom the piece that it's missing. And then go ahead and combine your numerators together. So there's the -3x, and then here's where I got my 2x plus 6 from. Don't forget to find your undefined numbers. So that's everything in the denominator. And it looks like you have two spots where we could be undefined. So just be sure you kind of pull that to the side for your final domain restriction in red. So plus or minus. So first, let's take a pit stop and look at a complex fraction, where it's a fraction divided by a fraction. So normally the way that we would tackle something like this is I would recommend rewriting it to make it look like division, because that's really what's happening here. So 1/3 divided by 3 divided by x. And then we get to do what we saw the other day, where we keep, if you like KFC, keep, flip, change, easy way to remember it. So I'm going to keep the 1/3, change to multiplication, and flip that second fraction, which gives me this lovely answer of x over 9, which is great. It will work. Let's look at a really fun shortcut. You'll kind of see you ended up with an x on top and a 9 on bottom. So 1 and the x got multiplied. So basically, we had this get multiplied, and then we ended up multiplying this. So that is actually going to be our shortcut. So if you multiply the outside, you're going to get this numerator. And if you multiply the inside, you're going to get the denominator. And that's how we're going to skip a couple of steps. So let's take a look at example 6. Okay, I first see the stuff in the numerator. I need to go ahead and do some common denominator. So let's try to make that a single fraction. Well, this has an x and this has a 2. So I'm just going to multiply the top and the bottom by 2. And this one's missing this x in the denominator. So top and bottom by x. So now I have a 6 plus x squared in the numerator and a 2x in the bottom, and the denominator didn't change. Now let's use that shortcut to multiply the outside. So here's the outside in pink. So these are going to get multiplied just like they did on our example. So x times 6 plus x squared, and we're going to multiply it by the inside. So that's going to give me a 2x times x minus 1. Now, simplify what can get smaller. So, well, none of these pieces match except for here. I do have an x on top and on bottom, so those are going to get eliminated, which is just going to leave me with this. And you'll see I kind of put x squared first. That's just a preference, but it's not wrong if you leave it as 6 plus x squared. And don't forget your undefined. Undefined, anytime something's on the denominator, that's a restriction. So you actually have 3 spots, 3 trouble zones for restrictions. So on that one, anytime. So this is on the denominator, this is on the denominator, and this is on the denominator. So 3 restrictions on number 6.